Hey everybody, welcome to the last section of Chapter 8. This is section 1.8, where we bring back a lot of old familiar formulas of different shapes and geometry. And specifically today we're going to talk about the perimeter, which is the distance all around a certain shape, and the area, which is basically the amount of the shaded region inside of a shape. So we'll be talking about outside with perimeter and inside with area. And a lot of these are probably a review, but if not, good, new stuff today. Now what I would do, friends, is I would maybe somewhere in a separate sheet make a couple of columns here to keep track. So we're going to talk about a lot of shapes today and in future sections as well. So it's good to keep track of all these formulas. So I would keep a column here of the shapes that we're talking about, and then maybe if there is a perimeter formula, you can have that, and if there's an area formula. Just keep yourself organized really, really well. Maybe on a separate sheet of paper or on flashcards are great too to help you memorize. All right, we start with the most standard one, and one is a square. Our friend the square. Now, it's sort of obvious that the area of a square is given a side of S and a side of S because he is a square. We'll talk more about these shapes in future chapters too. What makes a square a square? But just know if we have a square, the area, the shaded region on the inside, is S squared. Now because that's common knowledge, it's not a theorem, we don't have to prove it, it is just a postulate. So like we learned before, a postulate is just something that's already understood and believed. So there's your first formula, friends. The area of any square is the square of any length. And since they're all the same length, we can pick any side we want. Just say, well, the area is S squared. How about, for example, over here? You see we have a square over here, side of 7. What's the shaded area on the inside? Well, area should be side squared, and each side is 7, so 7 squared. Do you know 7 squared? It's 49. There you go. That's the area of that square. That's how easy that is. So area of a square, done. Let's move it up a notch. Let's talk about a rectangle. And rectangle is like a square, but the sides are not all equal, but they do all have right angles. And a lot of times we label this with a length, which is sometimes the longer side, and the width is sometimes the shorter side. But you can put those either place, and it doesn't really matter because the formula will still work. Hey, the area of this friend, this rectangle, is basically length times width. There you go. There's your formula. The area of any rectangle is the product, multiplication, of its length times its width, or L times W. Shall we prove it? Yeah, we will. And we're actually going to do this in one of our classes coming up. It is one of the coolest, neatest proofs. It's going to take a lot of algebra, but it is so clever. But we'll do that next time. How about some examples? First of all, can we find the area of each figure? Number 1, I just want to know what's the area of a rectangle. So already in your brain you think, okay, area of a rectangle is length times width. And the length here is 3.5 centimeters, and the width is 8. If you need to draw it, go ahead so you can visualize it. But if you don't need to, you can just go right for the jugular and find the area. The length here is 3.5, and the width is 8. All right. So the area on the inside should be length times width, which is 3.5 times the width, which is 8. And you can use a calculator for that. That's basically going to be 28. So the area of that rectangle is 28. And it doesn't really matter if you drew it like this or if you drew the long sides going vertically. You can still say if this is 3.5 and this is 8, believe it or not, this actually looks a little bit more realistic given these numbers. Either way, you'll still get length times width, and you'll get 28. All right. Okay, that's fine. But look at number 2. I love these kind of questions for number 2. Can you find the area of this given shape? And what the heck is that? It's not a square or a rectangle. It's kind of morphed into something very strange. Actually, kind of looks like the blueprint of someone's house or someone's floor. But, can we find some cool strategy to find the area of this strange shape? Well, here's one idea. What if we start slicing it up into pieces? As long as we slice it into pieces that are rectangles and squares, well, we're good to go. I could do that. And look what I just made. I made 1 rectangle here and 2 rectangle there. So we can find the area of each one and add together. Well, let's try that. Let's find the area of rectangle number 1. Now we need to know these sides. I see the side of the top of the rectangle is 10. That's fine. But how much is this length, or I guess it would be the width here? It's not 8. I know it says 8 over here, but 8 referred to the entire side of this figure, the whole left piece. So the whole side's not 8. Is there a way we can find out how much that is? If I know this whole side is 8, how about anything on this side? Do we know anything over here? Well, I do know this is 4. Oh, okay. So if that's 4, and that length plus this length has to equal 8, then are you a believer that this side over here has to be 4? Because 4 plus the other 4 would equal the entire side of 8 on the other side. Okay. So how about rectangle number 1 would be length times width. Oops, got a little excited there. There you go. And so the area here would be 40. Good. Let that sit and chill, and let's talk about rectangle number 2. Let's do the same idea here, friends. Can we find the length? That's still 7. And the width, it's given as 4. So all right then. How about 7 times 4, length times width? That's 28. So now how do we find the total area? Did you say, Adam? You're totally right. Let's add rectangle 1 plus rectangle 2's area, and we get 40 plus 28. I'll tell you, friends, that the entire area is 68. Great job. Now, there's another way to do it. There's actually many ways to do it, depending on where you cut this guy up. Check this out. What if we did this? You ready? Okay. Instead of slicing across the middle, what if I drew a line here? And now look what I made. I made another rectangle over here, rectangle 1, and a smaller one over here. It would actually still work. Finding the sides might be a little tricky. Let's see, on rectangle 1, the side on the left would still be an 8. And the side down here would still be a 7. So I think 8 times 7, that would give the area of here, that's 56. How about over here on this side? Well, remember before we said that this length is 4? How much is this one? I know this bottom length over here is 7, and we know this whole thing has got to match the 10 up here. So 10 minus the 7, this is a 3. Okay, so the area of rectangle 2 would be 4 times 3, or 12. Okay, now if we take the 12 of this and the 56 of this and we add it, guess what we get? We do. Pretty cool. Can I give you even one more cool way? All right, this is what's going to impress your friends. Ready? All right. Instead of drawing lines and cutting up into smaller pieces, what if we did this? Check this out. I'm actually going to do the opposite. I'm going to add a piece to the end. Whoa, look at that. So now I'm going to find the area of the whole thing, and then maybe I'm going to subtract this little piece over here. So my game plan is, can you find the area of this whole darn shape? And then we're going to subtract the area inside here. Let's try that. Let's see. All right, in the whole big shape, I've got 10. And over here, the whole right side should match the 8 that's over here. So I have 10 by 8. So the whole shape is length times width. That's 8 times 10 is 80. That's pretty cool. Now, I want to take away this little inner part that I added there because that's more than what I'm trying to find. But we need to find the length and width of that friend. Okay, well, we actually did that again on previous examples. If the whole bottom is 7, this whole bottom is 7, and the whole top is 10, do you see that this little small green piece over here has to be 3? So we get 7 plus 3 equals 10. And then, if I want to try to find out this side over here, we know the entire length is the 8. And then we talked about, I kind of drew over it. Oh, hello. That side is 4. So we didn't really actually need the 8. I thought I was going somewhere with that, and I was wrong. All right, how about the small piece? I think we have enough info here, friends. We've got, that is an area of 4 times 3, which is 12. Great, that's the yellow area here. But we're not going to add them, right? That's too much. We're going to subtract the whole minus the small. And 80 minus 12, you guessed it, it is 68. So many different ways to solve this problem. That's actually kind of why I like this kind of problem. You can slice it up any way you want and use rectangles and squares. You can add sides and make it a bigger picture and then subtract what you added. Okay, rectangles, check. Squares, check. And how about our friend, the triangle? We're going to deal a lot with triangles this year. So how about just a typical triangle area? Okay, for example, I'll put a right angle here. Sometimes we call the bottom part the base. And then the other leg of that triangle that's perpendicular, makes the right angle there, is called the height. And they have to form the right angle together. I snuck in the word perpendicular. Did you hear that? We don't really know that word yet. I'm sorry. You have no idea what I'm talking about. But this is a right angle which leads into perpendicular later. All right, our formula, friends, if you remember this, the area of any triangle is 1/2 base times the height. Now, I can draw this several different ways. How about over here? Look at this huge triangle where this long part on the bottom is the base, and as long as the height is making a right angle with the base has to be in a right angle with the height. As long as you have that, you're good to go. So I can't call this side the height over here, right? Because that's not making a right angle with the base. The height has to be a right angle with the base, and then we can play. Well, the area of this triangle, friends, is also 1/2 base times height. Now, it is unusual, but it's possible that you could have a triangle where the height is actually on the outside. For example, this strange triangle here that I just drew has a base here, but if I try to draw a height that's perpendicular to that side, well, where am I going to draw that? This is kind of weird, and we'll talk about it in a couple chapters, but I'm going to draw a special dashed line on the outside that would be perpendicular here, and so therefore this is the height. Area of this strange small triangle is still 1/2 base times height. But we won't see this kind of triangle too often because it's very unusual to have the height on the outside. We prefer the ones up here that have right angles directly on one of the sides or where the height is on the inside. Those are our two preferences. So here's your formula. Triangle, 1/2 base times height. Cool. Now, can we go back a sec and talk about on our square? We know the area of a square. Well, how about perimeter? Take a break from area for a second. If I take a square and all the sides are S, what's the perimeter? Remember, perimeter is you just adding all the sides together. So as you walk around, I have one side. As I'm adding the sides together, I'm just walking along the edge of the garden here. So when I add S plus S plus S plus S, all four sides, I get 4S. All right, well, why don't you put that? The perimeter of a square has a formula of 4 times S. What if you did that to a rectangle down here on the left? Let's use our same rectangle over here, and I want to walk around this rectangle and add up all the sides. Well, so far, I feel like I'm good to go. I've got L down here, and I've got W, but what's this on top? Ah, that's another L, right? That's the same L that's on the bottom. And so also, can you see that this is the same W that's on the right? Okay, because he's a rectangle, and we'll learn more that the opposite sides are congruent or equal length. So let's find the perimeter here. P for perimeter, friends. What's the perimeter of this rectangle? If you walk around, you should have a length plus a width. Keep walking, keep walking. So really, how many lengths do we have? Oh, okay. How many widths do we have? Okay. Why don't you write that formula down too, friends? The perimeter of a rectangle is 2L plus 2W. So now, square, area, check. Perimeter, check. Rectangle, area, check. Perimeter, check. Triangle, area, check. Perimeter, well, that's hard because we can draw triangles many different ways. And so really, we don't have a formula for the perimeter of a triangle. So perimeter can be different for different triangles, so there's no real hardcore formula for that, friends. All right, well, let's play some examples here back to area of triangles. Can you find for me, friends, the area of a triangle? So already you're thinking, okay, 1/2 base times height. With a base of, and a height of, Here we go. Area is 1/2 base times height. Well, that's kind of nice. Okay, I can just keep the 1/2 on the outside and do 8 times 6, which I think is 48. And then why don't we half the 48? Okay. There you go. That's the area of that triangle. So as long as you've got the formulas down, friends, these are actually pretty straightforward. So going back to that front page, it's really important that you fill these out. Flashcards, again, are good to help you memorize, but having this really well organized helps you remember and memorize these much quicker. All right, now we're going to talk about our friend the circle. Oh yeah, circles are great. But now we have a different word for perimeter. When you walk around a circle, notice that it's one single continuous straight line. Well, I said one continuous straight line, but isn't it really more curved? And you're right. So we can't really call it a perimeter, we call it a circumference. Circumference is basically the perimeter around a circle. So we're going to figure out what that is. And then how about the area of a circle? And if you've taken geometry or a little touch of geometry, you've probably seen the formulas, but we often get them mixed up. So let's get this down today. All right, so here's a long time ago what mathematicians did, because there was no Netflix or Amazon Prime, poor them, so they got a chance to figure out what's the area and perimeter, named circumference, of a circle. So they took a circle, and they said, all right, I want to find that perimeter, that circumference, so I'll insert a shape that we do know and love, and say, all right, I could find the perimeter around that, and that's pretty close to the perimeter in yellow, but not great. So let's take the same circle here, folks, but now let's add a side to that square, and let's put that inside. All right, what's that purple perimeter? That purple perimeter is more than the square's perimeter, but still not quite the same circumference of the circle I'm looking for. So they kept going, and they kept going, and they kept going. Poor them, with nothing else to do. All they did was this all day, drawing shapes in the sand, watching the clouds. And as they did more and more and more sides, you see that these sides are almost kind of pushing outwards towards the circle. So the purple perimeter is coming very, very close to the circumference of the circle. In fact, look at this chart. You don't have to copy this down, but it's kind of neat to see what happens. As we increase the number of sides of the shape I put in there, look at that, I'm going all to a shape of 100 sides inside there. Look what happens to the perimeter, aka the circumference. This is the perimeter of each shape. If it's 8 sides, what's the perimeter of the 8 sides? And R stands for the radius of the circle. We'll talk more about radius when we get into the chapter about circles, but I think many of you know that the radius is that distance from the center of the circle to any point on the outside. Okay, 10 sides. 20 sides inside the circle. Look at the perimeter of each of these shapes in purple. Look at that. And so we get 6.28 times R. And for those of you who know that number, you might know that we can write it in a different way. Okay, hold that thought. We're going to come back to that in just a sec. Let's look at the area. What's the area of these purple shapes up here as I increase the number of sides? Ready? Okay. With 4 sides, it was an area of 2 times the circle's radius squared. Let's increase the number of sides of the purple shape. Look what's getting closer and closer and closer to. After 100 sides inside, now do you know that number, friends? Ah, that one we know, right? 3.14 is the number pi. So it looks like the area, they proved that the area of a circle is basically going to be pi times the radius of the circle squared. And I'll revisit that in just a second. Because look over here, back into the middle. Now, if pi is 3.14, what the heck is 6.28? Oh, look, it's like I just doubled 3.14. I just multiplied it by 2. So they figured out that the perimeter or circumference of a circle was basically 2 times pi times the radius of the circle. Okay, so that was a lot of theory, and it was very, very boring and dry. So here, let's cut to the chase, friends. Here's your formulas. The circumference, aka the perimeter, of a circle that has a radius r. The circumference is c for circumference equals 2 pi r. That's where that 6.28 came from, okay? Memorize that. But do you guys remember, in circles we can have a radius. But if I take that radius and I extend it in opposite directions, I have another radius. But I also have another name for this whole line that goes straight across from here through the center here. Have you heard that line before? Yeah, that's called the diameter. 2 radiuses or 2 radii combine to form a diameter. So what we can do is we can take this formula and rewrite it. 2 pi r, I can say that's 2, let me just put it out of order by just moving furniture around. That's the same thing, right? I just move the pi and the r together. The reason I did that is what is two radiuses together? That's a diameter. So you could also say that the circumference of a circle is pi times 2r, or pi times d. We don't always use this formula as often, but it's kind of cool. I think we memorize the top one more often. Circumference is 2 pi r. And therefore, what we did up here on top with the area, notice that the area of a circle with radius r is pi r squared. Okay, so memorize those three formulas. Really, the top two are probably the most popular or the most famous. Circumference is 2 pi r, and the area is pi r squared. And remember, pi is about 3.14, or we can extend it just a bit. A pretty good fraction representation of pi is about 22 divided by 7. If you plug that in, that's actually really close to pi, believe it or not. So as we play with it, we're going to decide, are we going to use this one for pi, or this for pi, or should we just leave it as pi? Because that's pretty easy. All right, let's play. Ready? Number 1, can you find for me, friends, the circumference and area of a circle? Circumference, area of a circle with a radius of 6. All right, so here's our circle. We've got a radius here of 6. What's the area inside the circle? What's the circumference, the perimeter all the way around? Okay, circumference. Remember, our formula is 2 pi r, and area is pi r squared. You know, a lot of students mix these two up because they both have pi's, they both have r's, and they both have 2's in them. So just be careful of which one goes where. I always think of area is stronger than circumference, so area has the exponent versus circumference just has the 2 in the front. Okay, ready? Here we go. Circumference, 2 times pi times, what was the radius again? Oh, it's over here, 6. So we can multiply the two numbers together and leave the pi there. That would be 12 pi. I'll tell you right now, the circumference of that circle, friends, is 12 pi. Now, should we do anything with the pi? Should we plug in 3.14? You know, when in doubt, it's always cleaner to keep it with whole numbers and pi, unless they ask you for approximation and say, all right, can you plug in 3.14 and give me a little bit more exact? But in general, folks, leave the pi in there. It just looks cleaner. How about the area, folks? How about pi r squared? Remember, r was 6, so r squared. Let's do the r squared first. 6 squared, I think, is 36, and then we can multiply by the pi. The area of that circle, the shaded region inside, is 36 pi, which is just about, I'd say about 110 or so. How was that first one? Is that okay? Great. Number 2, critical thinking. Ready? I want you to find the circumference, c equals 2 pi r, of a circle with area of this. Well, that's interesting. So if I want to find the circumference over here, what part of that formula am I still missing? What do I still need? R. That's right. I got R over here in question 1, so that was pretty easy peasy. But over here, I don't have R for number 2. But we do have the area. So is there a way that we can sort of extract the radius from that? Well, why don't I use my area formula? Remember, area is pi r squared, right? So if 25 pi is pi r squared, can we use that to solve for r? This is actually pretty cool. Watch. If you have a pi on both sides, since these are equal to each other, I can kill off the pi's. And you basically have r squared is 25. Hey, what number do you square and get 25? You get 5. Okay, let's answer the questions. I think we're good to go. What is the circumference of that circle? 2 pi r, or 2 pi r is 5. And we can multiply the 2 and the 5 together, and the answer for number 2, friends, is 10 pi. That's a neat problem. I'm going to put a little star next to that because it made you sort of think outside the box, and you had to solve something additional that you didn't have yet. Cool. All right, the last one's a fun one. We're going to spend a lot of time in class doing these kind of fun puzzles. You see these sometimes on sort of Mensa or IQ tests, or even sometimes on the SAT, where they give you a diagram like this. You've got a square, and inside is a circle. You've got one side is 8. All right, well, I want you to find the area of the region between the square and the circle. What is the area of that region? Can you see where that is in the diagram first? Where is that? Okay, it's the area between the square and the circle. So I think it's right here. basically 4 times. All right, let's find this area. This is actually kind of cool. Now, in order to do this, we need a little bit of logical thinking here, folks. In order to find these little pieces, if we could find the area of the square and the area of the circle, how could I use those two answers to maybe find the purple region? Well, I feel like if we take one piece, like maybe we take the square area and we rip out and just rip out the circle area, you'd be left with the purple. Oh, so how about let's do square area and take away or subtract the circle area. Does that make sense? That's our big goal now. All right, let's try it. Let's do each one. Let's find the area of the square. Remember, the area of the square is side squared. And you see the side over here is 8. All right, so the area of that should be 8 squared, or 8 times 8, 64. Great. Now we're going to take away the circle area. So let's find the circle area. Circle area is pi r squared, not 2 pi r, but pi r squared. Now that's pi times r. Wow, well, what the heck is r? In my diagram, r would be here. It'd be from the center to anywhere on the outside. Anywhere. But what's that going to be? All I have here is an 8. Well, what if I did this? If this side over here is 8, do you believe that this side over here is also 8? Does that make sense? Do you believe that if I sort of move that side directly in the middle of my circle, that would also be 8? All these sides are 8. Well, what did I just draw right now in the middle? This is your diameter. So if that's 8, how much would just one single radius be? So if the whole diameter is 8, because the side was 8, then I think the radius would be 4. All right, shall we put that all together? Here we go. The circle is pi r squared, which is pi times 4 is your radius, squared. All right, that's pi times 16, or we can write it as 16 pi. Ready? We're almost done. Here's our goal. We're going to do the square, the entire area of the square, and we're going to rip out the area of the circle. Now, that 64 doesn't have a pi on it, right? So I can't combine these two answers at all. So this is actually the best way that we can write that. That is the area of the purple. How cool. So we took out the entire area and subtracted away the inner area of circles. Great job, folks. So again, just to sum up, you did square, area and perimeter, check and check. You did a rectangle, area and perimeter, check, check. You did a triangle, area only because perimeter can be a little tricky and can be varying depending on the shape. And you did finally circle, area and perimeter, which we call circumference. Great job today. We're going to play more about these special kind of shapes here from number 3 when I see you in class next time. Good job, everybody. See you next time.